So yesterday we discussed about uh, what is a thread, what is a process, and also we talked about the how real-time scenarios of threads and process, and we have gone through the computer system of Windows, how our threads are working, and whenever you create a process, how the threads are created internally. So thread will help you to always to do some work, unit of work, and it works parallelly simultaneously so that the program will work very efficiently. A thread has a life cycle. Whenever you create a thread and there is a start a new state, whenever it is come from new state, it goes to runnable state. Runnable means I'm ready to run, like ready to run, runnable state. And running state means actually doing the work. Whatever the work you assign to thread, it is working on that thread, on the work. In the meantime, while running in the runnable state, some of the cases, there is a time wait state, means that we can pause it for 10 minutes. You can pause it for 5 seconds. You can write sleep. Hey, go for a sleep for 5 minutes. So it goes for a sleep for 5 minutes or 2 minutes, however it is decided. And the second state is, this is a wait state, means that from the runnable state, it goes to the time wait state and it stays for some period. Then it come back again to the runnable state. Predefined time you have to define. This is the time you need to go for sleep. Runnable state. From the runnable state, it can go to the wait block state also. The wait block state is like from one computer, you are trying to connect it to the another computer. There is a network and there is a lot of network issues. A lot of network communication need to be done. Some cases, other computer also busy. Your thread will be blocked for some time. Then after you block for some time, you get an opportunity to come back. That is the one scenario. Second scenario of block is you created too many threads, your computer have a CPU is limited, and your central processing unit cannot able to give a sufficient CPU time to your thread so that that thread can go into a wait state or block state for some time. Once CPU will given a time back to your thread, then your thread starts working again. Then after the work is completed, it comes into a termination state. Any work, if you assign a thread, it will follow. Not necessarily it will go to time wait state. Not necessarily we can go to the block state. This is an optional states. It can depends on the conditions. Time wait state, you define it. As a programmer, you write a code. But this block state, you will not write a code. That is decided by the central processing unit of your computer. It decides that whether I have a CPU or not. I'll come to here real-time scenario also. So these are the main states of a thread. These are optional. There are multiple states again, but I'm not going to the too deep on this. But high level, start state or new state. Runnable state means running, ready to run, and running means actually doing the work. Then afterwards, it goes into terminated state, which is dead state. Means thread will go away. In between, you can go to time wait state. If you want to define your time, I can stay for 5 minutes. There are some cases we can say that time is state. Then there are some cases block status. If you see your task manager in your computer, let me open that task manager also. So when it goes to block state is, suppose your computer is CPU is 35%. Whole computer is utilizing CPU 30%. My computer has 100% of CPU. You might have heard about a 2-core CPU, 3-core CPU, 4-core CPU, right? Each core is 100%. 3-core means it is 300%. If it is 8-core CPU means it is 800%. Maybe you can club together into 100% also as a mathematical formula, but take for simplicity 100%. All cores. My computer is right now 2-core, means two my CPUs are there in my computer. And you might have seen the Intel 7, Intel 5, Intel 6. Whenever there is a new release coming, Intel 6, the new process is coming, the frequency, how fast the computer runs semiconductor devices also decides. Suppose here in my computer is CPU is keep on changing. You see that 39, 41 means my processors are working here. My computer is working. And you see that the zoom I'm using heavily now. You see that zoom is increasing the CPU. And PowerPoint I'm using it more. PowerPoint I'm getting more CPU. And also I'm using the Chrome. It is my CPUs are using it more. Most of the process in my computer, a task manager I'm using it. You see CPU has been increasing. If you go down, so a lot of my processes are running, but they're taking very, very less CPU. Means that the reason they are taking very less CPU, they are not that much active. They're running in the background. It takes very less amount of time of CPU. So right now, Adobe is taking 0%, right? Not taking too much. So Adobe. And in the active process, is not there. Let me see that. Let me open the Adobe in my computer. So I opened the Adobe PDF and I started using it this. Let's go to the CPU section. If you see CPU, Adobe came up upside and still it is 0.5. Let me use for some more time and go back here. And you see that it was going up and down. So the way I'm using it, the Adobe has been changed. It means that my thread is process. I'm talking about process here. Within the process, there is a multiple threads. And we are learning now threads. Collection of all the threads. So one thread use one CPU, another thread use one CPU, means process uses a two CPUs, two or more CPUs. Percentage I'm talking about. So suppose your program is, the reason I'm explaining this background information is all related to the block state here. Why it will go into block state? When your thread is taking a lot of CPU, means it is doing heavy duty, heavy work. It is computer sometimes do not have any sufficient CPU. It will give in a block state for some time, couple of seconds, and your process work will stop for some time. That is a one case. The second criteria is that you see the memory. Memory is your computer has 8 GB memory or 16 GB memory. If a memory is also full, then your CPU will be more. So vice versa. My computer memory is being utilized more and more. My CPU will increases more. Those are directly proportional. My disk space is utilizing more. My CPU also increases more. My network connectivities are increasing more. My CPU increases more. It is like your human brain power. You are very good at the early morning. As the days goes to your night, you're tired. You cannot work anymore. You want to go for a sleep. A human being, right? That is the one scenario I'm trying to explain here. The second scenario is, as you morning you are so active, and as you go night you are not able to active. Maybe you are tired or you are busy, or your thought process may not work that efficiently. Unless there is some emergency, that is a different thing. That is one thing. And you are talking with someone and you are answering it. Someone put a question to you, means that you are talking with one person, one thread you are utilizing in a human being, and one more person also talking with you at the same time. You said wait for some time. Wait, let me answer this question first. Do you say or not? It means that your process, your thread in a human body cannot answer two questions. Maybe you listen it, but you have to wait for some time. Let me finish this question and talk. Exactly the same scenario is going to be happening in the programming world also. Whenever the process is running and CPU is less and memory is less, because the CPU and memory need to be shared across thousands of threads in a computer system. A computer system will have a hundreds of processes and thousands of threads we can create. If we're creating more threads, more CPU being utilized, more memory being utilized, more disk space might being utilized. But if you are creating more threads, the CPU has to do a judgment. Hey, take this, you thread, take the 1%, you take 1%, take back again 1%, give to one thread. You see that this kind of mechanism is CPU is doing background, and sometimes your thread may not get a CPU or memory. That is the case. It goes into a wait or block state. Then come back to the running state again. Then it goes into terminate state. I will pause here and trying to explain not only the thread, I want to link it to the real life, and also I want to link to your computer architecture also, your how the operating system does the work, and also how your CPUs are working behind the scene. This concept is similar. It doesn't matter it is a Java or it is any programming language. I will pause for questions here. If you understand this concept thoroughly, then you no need to read also what is the threads means. Please ask any questions.
Sure. Time waiting state.
Yes. Time waiting state is you as a writing of code, you put a time. Sleep for 5 minutes means don't do any work for 2 minutes. You decide it. You give a pause to your work for 2 minutes. Like you take a break, right? In between while doing a work, you take a break for 1 second, 2 seconds, 3 seconds. You can give breaks. Programmatically, you can give a break for 1 second. Programmatically, you can give a break for 2 seconds. There are some cases we need to give that kind of breaks because 2 or 3 threads are working together on the same task. One, like, you assign a one task to 2 kids, they fight each other, right? To solve the problem. So then you put a rule, hey, first this person is working, you wait, take a turn afterwards. Similar way, it is working on 2 threads are working on one task. Some of the cases they don't want to, 2 threads don't do not fight each other. I mean to say, they do the same work. We put a sleeps in between to collaborate the things, synchronize the things. So next is the process and threads we talked about, how to create a thread in Java program. So far we talked about threads, then we are now implementing how to create a thread. So there are two ways we can create a thread: by extending a class called thread in the java.lang package, Java lang package, and by implementing a runnable interface. Actually, the main thing is thread class is the creating a thread. This thread class also implemented a runnable interface. So if you go to our Java API documentation, then we can understand what we are talking about this thread class. Again, I'm referring to java.lang package. And if you go inside java.lang, you see the thread class. This is the thread class as written by Java as a part of it. So, so this has written all the methods. I just told, right, thread class is implementing object class as a super class. All all the classes, whatever you are going to write in Java, all are extending from the java.lang object. It means that everything in Java, whatever you write are subclasses. What is super classes? Is the object class is super class. Assume that. And thread is implementing one more interface called runnable interface. So if you go inside your thread, what is there inside? The thread has a constructors. So thread has a constructors. Thread also have some kind of a nested classes. We talked about nested classes, and it has some uh, variables, int static, maximum priority, minimum priority, norm priority. You can define a priorities to your threads. And the thread as a constructor. This is the default constructor. You don't need to create, it will be there. And there is a thread. It takes a runnable interface. Thread, runnable target, string name. You can give a name for the thread, whatever the name you want. Thread group. You can group multiple threads into one group. This is called thread group. And like the way it has many constructors. You know the constructor. I don't need to explain. To create a thread, you need a constructor. Default is the default constructor, no parameters. And thread has a lot of methods also. You see that current thread, what is the current thread, thread dump, enum. It's a lot of get ID of the thread. There is a lot of the methods which you need for the thread. But out of this, the important what is the important method is run. Let me see the run method. So this is the very much important. Run means running state. Whatever the code you written in this run method, whatever the code you are going to write in this run method, that will be executed by a thread. So this is the important thing. Even if you go to the interface of runnable, so this run method is coming from a interface of runnable interface. Since it is a interface is runnable, we define a method called run, and we don't have any implementation. This interface has been implemented by thread class, and that thread class is using this run method. So this is the Java API documentation. Let's get into that, how to write a thread. There are the two ways you can write a thread, as I mentioned. One is that using a thread class. Second one is using a runnable interface. The primary is that even though you use a runnable interface, we need to use the thread class. So the one way is creating with the thread class. So better to zoom your computer. So we wrote a class called public class test thread extends the thread. It means that test thread is become a thread for you right now. And we wrote one run method. I told run method. Whatever you write in the run method is actually the unit of work for a thread. So whenever you start a thread, it goes to which state? Runnable and running state. So whenever a thread is started, it goes to runnable running state, means whenever it comes to running state, it will come to this method and try to execute the whatever the code is there in this method. And once it reaches to the end of the line, the thread will die. In between, I put a thread dot sleep 102. You see that someone asked, what is the time waiting? I have given some time, wait for some time. Means that while I am working on the runnable, I am asking to thread to take a rest for 102 milliseconds. 102 milliseconds. I said, don't do any work for 102 milliseconds. Then do the work afterwards. So I wrote here very simple for class, for loop, which will print the 10 lines. And there is a main method I've written, and I created a test object is equal to test thread object is equal to test thread. I created a method. And what I did is I created a thread dot start, which is called, I'm creating a new thread here. So here I define a thread. Here I am created a thread dot start method. The start method is extended from thread class. I don't write any start method here. You see that? But start method is I have inherited from thread class. As soon as I invoke thread dot start, this thread is a child thread, because main thread is there already. Public static void main, whenever you invoke a java dot test thread and hit enter button, one thread is created already by JVM. That is called main thread. Then the main thread starts coming and executing this guy. And it starts executing this guy. As soon as you execute this line of code, it turns into a child thread and starts working here. And your main thread still comes down and go to execute these lines of code. This thread is working here and main thread is working here. And the main thread continue up to these lines and complete this for loop. This thread works on this for loop. This is how this test thread will work. So let me share this Java class, or you can write this Java class in your computer and you can test it yourself right now. See it is working or not. We'll come to that part. This is a way of creating a thread. Here is we assign a task. The second way of creating is by implementing a runnable interface. So test thread runnable implements runnable. And runnable interface is a method called run. So I wrote a run method, almost same like this. There is no difference. You can write whatever you like inside. And I have created a class, main method, and created object for this test thread runnable. And until that, this is not a thread. I have defined an interface and I have implemented thing. Now I need to pass this object into my thread class. As we see that constructor in the previously of thread class constructor takes multiple parameters. One of the parameter it takes is the runnable interface. If you go back to here, my constructors of threadable, you see that thread is a default constructor. Thread also takes a runnable interface as a parameter. The runnable interface is a parameter it is taking. This is the runnable interface. So exactly here, this is the object is a runnable interface. I am passing this runnable interface inside the thread class. Now I created a thread now. Now T1 become a thread now. Now T1 dot start, same thing. T1 start dot start. T1 dot start, then it will work on this run method. And the main method still continue on the same thing. So only difference here is the creating by extending the thread by implementing runnables. Here I have not extended the thread. Instead of that, I have implemented a runnable interface and I have passed that object into a thread class as a parameter. The reason we write like this is because suppose you want to write a class and implements a runnable interface, and also you implement two more interfaces and you extend a different class, and still you can write a thread. Here, if you extend a thread, you can't extend any more class in Java. You can extend only one class in Java. Whereas implementation, you can implement multiple interfaces you want. There is no limit interfaces, and you can extend a different class what you like for your needs. So that is the way they have given the two flexibilities, whether you want to simply extend the thread class and write a thread, or implement a runnable interface and you build your own custom functionality and extend a different class instead of thread, because only one class can be extended, and you still write a thread functionality by passing a runnable interface inside into thread function, thread class as a constructor. Still you can do t1.start. Here also you click on the start method. Here also you are doing in the start method. As soon as you invoke the start method, the request goes to here and runs the program. That is the way. This is the two ways you can create a threads. So just type this code in your computer, zoom it and type it this code in your computer. You can understand and run it in your own computer. Then you might see this. Let me see that I have already done it. Let me see demonstrate this. So first I am compiling the uh, test thread extends thread class. So I'm working on this class first. So if it's then I am going to run this class. So as soon as I run this one, see what is happening here. It came to line number 25 is completed, 28 is completed. As soon as 28 is completed, it invokes a start and it went to this person. That is the reason after this one, it printed a thread started running. Thread started running more. So it printed two times this one. And in between, the main thread, it is going down. My main thread is going down. The main thread is going down. I gave a sleep here to this guy to sleep for some time. The main thread went and executed this, printing the numbers 1 to 100. It finishes this 1 to 100. It finishes up to 1 to 100. By that time, this person is sleeping. That is the reason it is printed. And then afterwards, it woke up and it printed the rest of the work. You see here, the sequence of lines executed is different now. Suppose I change this one to 1 second, 1 millisecond. So you see the pattern here. First, it printed only two lines. First printed only two lines of more. And then it printed the main thread. This is the main thread, main method. Then let me compile. I change the sleep time now more. So now I execute it, see what will happen. So the way execution is changed now. You see that now The child thread working actively, it executed for loop this many times before the main thread from there to come here, this for loop. So main thread came here, it started working his own work. It printed up to 6. While this is working, and this guy also run one more for loop. So that's why it printed again. And what run one for loop, this also running one for loop. 7 is printed again. After 7 is printed, again this one run one more. Means they are working very simultaneously. That is the reason you see the print is varying different way. So it printed again 7. And again it printed more, one more time, this for loop. Then it started going fast. We cannot control how they are executing behind the scene, all because of the CPU utilization. You see that the pattern is different. I just changed the here 1 millisecond sleep I put. That's how it went. Suppose I change it to 0, so there is no sleep time. I make it 0. Let's see what will happen. Let's compile now. So let's see what will happen. You remember the patterns, the first pattern, how it executed, second pattern. So this will change again. So that now I made it 0. Since I gave a no sleep for this thread, as soon as you invoke the line number 32, it went and finished off this for loop very quickly. And the main thread, it reaches to here. By that time, it completed all the work here. And main thread is started working here. Means the thread, this task completed very fast before it came here. It means that this task has been completed very quickly and 2 threads are working, doing the work parallelly. I hope you have understand this how the threads are working. So let me use this same line of code, and you can download it. It is there already in the examples, but you can also take this and you can execute in your computer also. So I'm stopping my screen share for some time. I want everyone to write this class in your computer and test it and adjust the sum of the things. Sleep, thread.sleep, and you can write for loop to 10 to 100. You can increase the for loop to 100 to 1000. You can do whatever you want and put more uh, system.out.println, however you like. I want you to feel like how the thread is created and executed. And I shared this example also. The same thing, concept is same. Only thing is that runnable interface is added to thread. And you practice one example yourself, run it and do the work. Then how the threads are working, you can understand. Why don't we do that work right away?